Can you hear me okay? All right, good. So I want to talk about some of the things involved in actually building the car. And, first to the advisors, remember that the students have never used any of these tools before. Most of them have never used these tools. They haven't even seen these tools many times. So the first thing you got to do is to show them the tools, tell them the names, teach them the names so they can look for them and converse back and forth about what they need to do a job. And then you have to teach them how to use the tools. And there are all kinds of ways to use tools. I mean, a lot of them will grab a crescent wrench and start banging on something, like it's a hammer, but it's really not a hammer. So you have to teach them what a socket is, what a metric socket is, what an SAE socket is, what a Allen wrench is, all of these things. So we put together a board like this. We had this over at Crowley High School here locally, and it has basically all the hand tools you need to build a solar car. And we would have somebody who, we'd ask them for a 1/2-inch open-end wrench, and they wouldn't know what that was. So they'd have to go over there and look and say, oh, here's an open wrench, and I need one that says 1/2 inch on it. So we really got where we use that a lot. The students would look at it and kind of familiarize themselves with what they needed to use and what the names were. And before long, a lot of problems went away. So it's important that you take some time to show them what the tools are and certainly how to use the tools. Every one of those tools is a simple machine, so to speak, but you can still get hurt using almost everything on there. You can even be pulling on a wrench and it slip and you hurt your knuckles, as we all know. Of course, you can get hurt with a hacksaw or a file or anything. You can rub your finger across something. So it's important that you take time from the very beginning to explain what the tools are and how to use them, and also how to take care of the tools. Put them back in the toolbox or put them back where you got them. Otherwise, they just end up all over the floor and you can't find what you need. Another thing about tools, most of the teams go out and they buy a big toolbox and a complete set of tools that goes from like little small things way up to 2-inch sockets or something. You're not going to need stuff like that. You're going to need several of one thing. You're going to need 3 or 4 Phillips head screwdrivers. You're going to need 3 or 4 3/8 wrenches, 3 or 4 10-millimeter wrenches, things like that. So I found it's better to go to a pawn shop and buy the sizes you need, which may only be 4 or 5 wrenches, but buy extra ones so that somebody over here is not waiting for the 1/2-inch wrench. And someone over here is not waiting for the screwdriver. And we actually had that happen where we put our car together with hundreds of little screws, and they were all Phillips head, cross point, and we'd have 3 or 4 people waiting to borrow the screwdriver. So, get multiple tools of the ones you use all the time and just put them in the same place. We use these little plastic totes, and that worked pretty well. All the screwdrivers would be in one tote, all the wrenches of certain size would be in another one, and that worked out really well. Eventually we got a toolbox, but you don't really need a toolbox. You can put everything that you need to work on a solar car in a cardboard box that big if you really wanted to. So I recommend you have some way of teaching the students, and you students need to learn the names of the tools, and you need to learn how to use the tools. And the next thing is let's talk about safety. You have one set of eyes and you have one set of lungs, so you've got to wear safety glasses. And they're uncomfortable at first, but after you get used to them, they're not a problem. Just wear them all the time and you won't have a problem. Safety glasses have saved me and people that work for me many, many times, because you just never know when you're tapping on something and a little piece will break off and flip up into your eye. And I've only had that happen one time after 40 years of working with this stuff. And that was really uncomfortable, so you don't want to have that happen. I had to go have it dug out of my eye. And the other thing is wear a dust mask. When you're sanding something or grinding something, all those little particles get in the air. And And you'll notice if you're sweeping the floor and the sun's coming in, you'll see all kinds of particles floating around, especially if you're working with fiberglass. So you need to learn to wear those safety items. You need to wear a dust mask, and you need to wear safety glasses. And if you're used to it, it's not a problem. We even wear hearing protection, both the plugs and the ear muffs, when we're doing grinding or something like that, because it is hard on ears to listen to all that sort of thing. So main thing is train yourself, take care of yourself when you're in the shop. You know, you need a clean shop, you do need a place to work, and you need to have room where you can walk around, and you need to keep the floor clean. So if you spill liquids, mop them up. If you have electrical cables all over the place, pick those up, organize things. So to make sure you don't have a problem. Okay, now let's talk about battery powered tools for a minute. You know, you get these, I've got a torque wrench that's a Ryobi torque wrench you can take wheels off and things with, and it develops a lot of torque. You can actually, when you're drilling a hole or something, you can catch one of those and they'll whip around and hurt your wrist. So you need to be careful about that. 110 volt stuff like power saws and saber saws, all that stuff is dangerous. You just need to learn how to use the tools, and then once you learn how to use the tools, you'll use them the rest of your life, because it's a great asset to know what a tool is and how to use it. I mean, if you're repairing something at home or on your car or bicycle or whatever, it's nice to know how to use tools. Okay, mechanical machines that we use, we have benders for bending material, we have presses for pressing material and bending it. We have brakes and shears. The shears, that's the machine that comes down that cuts the sheet metal, and the brakes, the material, is a machine that folds the sheet metal. Is this on? I can't hear it. Okay. All of those things are dangerous, but if you have someone with you that knows how to operate them, has operated them, you shouldn't have any problem whatsoever. But always be careful about where you put your hands, especially on table saws or anything that's rotating like a lathe or a mill, bandsaw, table saw. We've got all those tools and we use them all the time, but definitely always be where your hands are. Don't wear loose clothing like this. I'd have to pull this up. It's okay to wear gloves, but be careful that your gloves don't get caught in something. If you have long hair, you should pull it back, because you can lean into something like a lathe or even an electric drill and get your hair caught in that, and it'll wind your hair up faster than you can ever believe and hurt you pretty hard. So be careful about those kind of things. Okay, I've got over here another board that has materials, and we'll talk about design in just a minute, but I want you to see some of the materials that go into building a solar car. On the top we have some aluminum. The first two pieces, one is a 090 aluminum and the second one is 063. We built a monocoque car and we used 063 aluminum in the entire construction of that. We also used some 040 on some of the side panels that didn't need to be quite as strong. The bulkheads are made of the 090 material, a little bit stronger. After that, there's a piece of honeycomb fiberboard. That's actually some material that Mr. Carraway bought. I believe it's originally designed to be used on the floor of a 707 aircraft. The second piece is a piece of cardboard lining, and I've actually taken that. That's like a packing material from something from Amazon. But I've actually taken that honeycomb and laid fiberglass on top and bottom and made a pretty decent beam out of it. So those are things that you can get for nothing and actually make something out of them. And the last piece over there is a piece of 7-ounce mat. That's just one piece of fiberglass laid up on a flat surface, and it's surprisingly strong just by itself. The second row down there, I've got a disc brake, which just gives you an idea for people who have not been around solar cars much. That's a disc brake caliper on the bottom and the disc brake right above it. And of course, it squeezes on the brake disc, and that's how you stop your car. Next to it are some components, and that the angle aluminum is just from Home Depot Low type stuff. It's made by Macklemore Duncan up in Oklahoma, but it's just a low-cost piece that you can use for making mounts, seat mounts, all kinds of things. It's available in different thicknesses. If you're going to make anything having to do with an array or something like that, you want to use a thicker piece than what I have on there. The second piece is, or the piece on the other side of that is a 2-inch tubing for a roll bar, give you an idea of what a roll bar tube looks like, just the raw material. And after that is a series of tubes. Building a tube frame car is one of the easiest things to do for your first car. And it's easy to weld. This is mild steel. It's easy to fabricate. You can cut it and weld it really easily. That's available in all kinds of different sizes. That's 3/4, 1 inch, and I believe 1.5 inches, and those are the sizes we use for the cars we build. And the last piece on the end is a piece of 1/2-inch Schedule 40 pipe, which is just 1/2-inch pipe you can get at any hardware store. And that's all we've ever used to make our suspension pieces for. It's called 1/2 inch, but it's actually 0.840 inches in diameter, and it's 1/10 of an inch thick. And if you run the numbers on that, that's a pretty strong piece of tubing for doing what we're doing on suspension. The next line below has a couple bearings like the ones we've used for our motor mounts and our suspension members. There are 1-inch bearings in there, but we've since gone to 1.25-inch shaft on anything that we do. One is a flat cassette, and that's called a flange mount. And then the one that stands up is a pillow block mount. And those are pretty good for our application. They're pretty heavy duty, and you can use them to make mounts and have things that need to rotate. You can get them in smaller sizes and use them for steering shafts, actually. They work real good for steering shafts. The shaft is a 1 inch, actually it might be 1.25 inches, keyed shaft. It's a hollow shaft, and so a lot of our drive shafts we use are hollow to save a little weight. The next line down has 2 sprockets. One is a number 35 chain sprocket, and the one next to it is an aluminum belt sprocket for a tooth belt. And we've run both of those with good success with both. The number 35, the smaller the chain in its pitch, and the number 35 is a 3/8 pitch. That's the distance between the pins on the chain. The smaller the pitch, the less drag you have when it rotates. So if you get a big chain that may be like a motorcycle chain or something, it'll have more drag than a number 35. So we ran the 35, several teams have run those. They aren't built for real heavy loading, so you need a light car to do that. If you don't have a light car, you might want to go up to the motorcycle size. Other than that, we have 2 bearings there, just an example of what we call rod-end bearings, something you would use on your steering or your suspension. And there's the male and female. The male has a threaded shaft, and the female has an internally threaded shaft. And you can put those together and make an adjustable link, actually, if you wanted to. Then on the bottom, I wanted to show some of the wiring stuff. The split loom is a piece of plastic that looks corrugated, but it's split in such a way that you can run wire into it and you can pull wire out easily. And it makes for a nice conduit that you can slide over things. And I've just finished working down in Houston on a big project, and there was a Canadian guy there, and he had we had about 40 feet of wire we had to put in that split loom. And he took a wrench and put the wrench over the wires. And I don't know what a boxing wrench, and I don't know what he was going to do with that. But that wrench was the right size to slide into that split loom and just spread it a little bit. And then he literally took that and just drug it across that wire and put all that split loom in there in a matter of seconds. And I didn't know how to do that. I'd never done that before. I thought that was pretty cool because it saved a lot of time and saved your fingernails too, because I've always had to pry that apart, stick the wire in. So I learned something there. After that, there's a couple of samples of terminal blocks where you can make connections. And of course, you always want to kind of cover those terminal blocks so they're not exposed. but that's to give you an idea what what they look like in the exposed condition. And there's a way of putting those together where you can see where they are. On the wiring, you need to label those wires somehow, and you can do it with color. You can do it with tape. You can get little tags that go onto them. Some of them are snap-on, and some of them are you wrap them on, and they'll have numbers, so that all your wires are numbered. And that's an important thing to do. That way, when you're trying to troubleshoot something on your vehicle, you can see that it's a number such and such. You go to your wiring diagram, and it should call out that number. And that's assuming you have a wiring diagram, which you're going to have. After that is what's called DIN rail. DIN rail is a fabricated thing that's stamped out piece of metal, and you can slide all kinds of terminal blocks on there. In this one, I put a circuit breaker. You can slide circuit breakers on there and all kinds of other connections. And DIN rail is inexpensive and really a nice way to put your wiring together. The next two pieces are surface-mounted raceway, and that's a great way to run different stuff. We ran a lot of our wires through the array mount that we had built. Unfortunately, we also drilled some holes in our array mount, and we got into our wiring a little bit, and we had some shorts. So I recommend you do something like this. Number one, it's non-metallic, and you can get these at all the big box hardware stores. And that non-metallic is great. You don't short out to it. And it can actually rivet, or it can just has sticky back tape on the other side, and you can stick it to just about any surface. So those are ways to wire up your car and protect the wiring, but you also need to label the wiring when you do your schematic. The other things I had here, I haven't talked about welding yet, but these two welding machines, one's a machine, and for those of you in the back can't see it, but you can come up and see it. It's only about, well, I'll lift it up. As you can see, that's really lightweight. That is a little MIG welding machine from Harbor Freight. I think I paid $135 for that. It was on sale. And I just bought it because I wanted to try it out. And the best part about it is it's portable. You can throw it in the back of your car if you're going to go somewhere. You're going over to work on the car at some place or work on a part. It uses, there's a larger one that uses gas. That one uses flux core wire, so it's completely self-contained, and it'll run off house current, which is excellent. The other thing is a little bit heavier, so I won't lift it up, but it's a little gas rig, and with it you can do all kinds of brazing, and you can actually gas weld with it, especially the size materials that we're talking about on our car are not that big. But I think I paid in the area of about $600 for that, including the gas and the bottles and everything. And that's incredibly cheap for a welding machine. So with those two items, you can cut metal with this one, and you can also heat things up so you can bend them. You can braze with it. You can weld with it, and it's completely portable. You can throw it in your car and take it with you. So those are two items that for probably under $1,000, you can have a complete welding setup for either brazing or welding. And you're not going to be good at this unless you practice, like all of these skills. So you get something like that, and it takes a few days of playing around, building a few things, and then throwing them in the trash. You don't want to learn on your car. You want to learn on some other material, and then after you feel confident, then you can work on your car. But they're quite capable of doing everything you need done. And now they won't weld aluminum. You can actually put the right gas in here and have a low enough temperature that you can kind of braze the material, the aluminum, with some of the light alloy stuff that they have available. But this will give you some idea of the material that you can use. And these are some of the tools, hand tools you need, and some of the welding equipment you could use. I make extensive use, and all our students do, of hand grinders that we put cutoff wheels on. And that's a great way to cut tubing. You know, you can buy a chop saw, and that works really well too. But it's, you know, if you got a 20-foot piece of metal, it's nice to be able to walk over an extension cord and a little cut-off tube and just cut off material as you need, and you don't have to drag that big piece of material around. But they are dangerous. You need to be very careful with them. If you're cutting something, you have to just maintain a straight motion all the time. If you twist it, it'll break the blade. And if it breaks that blade, the parts are going to go up in the air. So you want to be very careful about that. Always, always, always wear safety glasses whenever you use any kind of grinder like that. But those things, you can put a wheel on them, and you can buff things, or you can wire brush things, or you can cut things, or you can grind them. Talking about welding, soldering is not welding, but soldering is a real talent, and I don't know very many people who can solder properly. I certainly don't do a very good job of it, but I have met some people who are really good at soldering. But that's the first form of attaching two materials together, and you should learn how to do that. And we have plenty of things that need to be soldered. Almost all the connections on the solar car electrical circuit need to be soldered, so where you put all the lugs on. Brazing is the next step. In brazing, you don't actually melt the base material, the two pieces you're trying to attach together. You heat it up, and when you put the brazing rod on it, it diffuses into the surface and becomes part of the surface. And so you can't really grind it out. It becomes part of the surface, but it is a surface treatment. You're not melting the base material. And brazing has a lot of applications, especially for really thin sections of material that don't weld very good. They're really too small to weld. Brazing is good stuff. You can get something up to a cherry red color and then apply your brazing. It's used extensively over in England, and used to be used for all race cars, and certainly they still use it for bicycles and all kinds of things like that. Although bicycles now are made of carbon fiber probably. But brazing has you can get some materials that go up in the 60,000 PSI tensile strength, and that's really high up there. Stick welding is the next thing, where you have a little stick and you cause an arc and it's consumed, and it has the flux on the outside, and that will float to the surface, and then you break that off. And that's a real talent. I'm not real good at stick welding, but I can do it. But it's hard to stick weld the kind of stuff that we're working with. MIG welding is much better. Stick welding is just too hot, and it melts through the base metal for the kind of wall thicknesses we're dealing with. Next, I'd say MIG welding is probably the ideal tool to use for what we're building. And there's a gas flux, where you have a little machine like this, and it has a bottle, and you have a gas that comes around the weld and prevents oxidation of the weld while you're doing the weld. But it's inconvenient to have that bottle, and I'm always running out of gas. So I like the fact that they have a flux core welding wire, and in that, the flux is contained in the wire, and as you weld, it floats to the surface and prevents oxidation. So, you know, my choice is MIG, and it's extremely fast. So MIG is a pretty good method of welding. The last is TIG welding, and TIG welding is really the best thing to use when you're welding aluminum. Although you can MIG weld aluminum, but TIG welding is really the choice deal. And TIG welding has a little tungsten electrode that sticks out, and usually for a non-ferrous material, it's going to have a high frequency option, and that high frequency jumps back and forth from the weld surface really quickly and breaks up the oxides and allows you to weld aluminum and magnesium and titanium and things like that. But you can also weld stainless and mild steel with it. It does a beautiful job. So those are the basic welding methods. You definitely want to have some kind of eye protection, you know, like a hood. If you're doing the welding, you don't want to close your eyes at the last second and try and do something, because you'll get some blistering of your eyeball, and I've done that, and it feels like sandpaper in your eyes, and it's really uncomfortable. So avoid that. And you also need a screen or something to protect other people in the room, because when you're welding, you're going to create an arc, and that arc is, it can be looked at, you can look from here to the other side of the room and see it, and it can damage your eyes. So you've got to have a screen of some sort to protect the other participants around you. All right, we'll talk about car construction a little bit. There's basically 4 ways to make a frame for a car. One is the ladder frame. The ladder frame was used for just about everything, including horseless carriages and horse buggies back in the day. And the ladder frame is just like a ladder. You lay it on the ground and you have 2 main runners and cross beams across. And then you bolt on your suspension and that's your ladder frame. And you still see ladder frames. Some famous cars like the Shelby Cobra was a ladder frame. And of course all go-karts are ladder frames. So they have their place. The next is the space frame. That's where you have a top and a bottom frame and they're connected by tubes and diagonals, and that member is stressed so that it has torsional rigidity. You say, well, what's torsional rigidity? Well, torsional rigidity is the ability for the chassis to do its job, which is hold everything together and not twist. Because if you spend a lot of time working on your suspension so that you have your wheels pointing in the right direction, and they're straight up and down, and they have maybe a little negative camber, and they have a little bit of caster so that the steering is self-centering, and you make a great deal of effort to make all that work, and then your chassis flexes, then you lose all that. You know, your chassis flex is a bad thing. So I have a little gizmo I can show you here. This is a standard Skechers box for shoes. And you can see that when I twist this, you have twisting of the box. It doesn't take very much to twist it. But if I put this top on here, all of a sudden it's rigid as can be. So I'm going to pass these around so you can play with them. Yeah, pass that back. Don't mind waiting. Oh, sorry. There you go. So that's a sample of torsional rigidity. And that's actually a big deal. And a space frame allows you to have that in a lightweight welded structure. And I've built a lot of space frames, and the students have built a lot of space frames. And we've found that using square tube works just as good as anything and is lots easier to fabricate. You have to miter these tubes when you're welding them so that they're really close. You don't want big air gaps. You don't want to have to fill that with weld. You want the pieces to actually touch. And to do that, you miter them so that at the angle they come together, they touch all the way around. Square tube is much easier to do than a round tube. So I recommend you use square tube. The next style from the space frame is the monocoque. In the car industry, a monocoque is called a unibody. And so cars came out in the past, they had a frame, you set a body on top. Then the unibody came out, like the Ford Mustang is a unibody. And it was just one stamped out piece, all welded together. It had rigidity. So the monocoque is a variation of that. If you've ever flown an airplane, all airplanes are monocoques. They've got basically a big tube, and that tube has the rigidity and holds everything in place. So we built a monocoque car. We built a couple monocoque cars and folded them up out of this 065 aluminum. That's a either 5052 H32, which is a number for the aluminum, and the number tells you what the alloy is in the material, and the H number is the hardness. So that's a easy to get material. 063, you can actually bend it almost by hand, and you can make a little bender out of 2x4s or out of angle iron, and you can find all that stuff on the internet on how to do. So that's the monocoque, and then the step up from the monocoque, the metal monocoque, is the composite monocoque, where you put everything together in with carbon fiber or fiberglass, and that's a completely different kind of thing. You can do it different ways. A lot of people are doing it now without a mold, where they take materials such as foam, and they sand it to the shape they want, and they lay something over that, and then after it sets up, they remove the foam from the backside. And there are different ways to do that. They have a material called peel ply that you can put on that, and then you can strip off as much of the foam as you can and then pull the peel ply off. So that's one way to do it. Another way is to make an actual mold where the inside of the mold is what you want the outside of the part to look like. And you can lay that up. A lot of that can be done by hand, one layer at a time. I've been kind of studying this a little bit with Burt Rutan, who I think Burt Rutan recently passed away, but he is the inventor of just about all this composite stuff for airplanes. And I bought a book of his on how to do that, and he's very much in particular talking about how you lay the mat so that it's a cross weave. It's not laid up like this or like this. It's angled in relation to the loads. And so there's a little bit of history in that comes from the aircraft industry that you can look into. You can pick up books or watch YouTubes about this stuff. But that's real important when you're building anything that's going to have any structural content. Now, if you're building a body, that's not necessarily going to have structural content, but it might have that. If you're going to build a composite frame, everything in it's going to have a structural component. So, talking about designing a car, though, you need to do some research. If you're going to build a car and you start with a clean sheet of paper, look at other people's cars, read the rules, decide what you want to do as far as what class you want to race in. That will determine a lot of things. And then make sketches, sit in a group, talk about what you think you should do, draw these things on paper, list all the ideas, make a model of what you want to do. You can make cardboard models, you can make plywood models. We made full-size plywood models for the cars we built. Look at everybody's concepts other than yours and glean from that some ideas. You can read books, you can use the internet, but finally you end up with a piece of paper and a drawing. So you need to learn how to make sketches and you need to learn how to draw things. Fortunately, we have an agreement with a CAD company, and so you can get copies of this program and you can learn how to use CAD, and I recommend you do that, especially if you're interested in engineering. But definitely learn how to draw things. And you can get a sketchbook, and you can fill that sketchbook up with things that after you've been drawing for 6 months, you'll throw that book away because you'll think, well, that's terrible, but that's just the way it is. You've got to start with the basics, learn how to draw a box, then learn how to draw a curve, etc. But learning how to draw things is really important. It helps you express what you want to do to somebody else. It helps you develop ideas with another person, with a teammate. So I recommend you spend some time learning how to do that. Start with a layout, then do maybe a full-size drawing of the thing that you want to make. And definitely, if you want to make something out of wood, we've even made things out of where we're going to build a tube frame. We've made them out of PVC tubing. But that's great for the model, but don't try to race that, because I've seen some cars that had supports for the array out of PVC pipe, and that wasn't suitable. If you're going to weld, learn how to weld. Take time. You're going to take several weeks to learn how to weld properly. But if you do that, you'll really be proud of yourself. You'll really be happy with the results because you practice and you get good results. You'll like all that. Suspension, you have to decide you want like double A-arm suspension. That's 2 pieces that move in unison like this. You want a straight axle. Are you going to have springs? Are you going to have rubber bushings? Are you going to have shock absorbers? Those are all things you have to figure out. The design of the brakes, you have to decide which brakes you want to use. Are you going to use disc brakes? Or you can use dual caliper brakes? You can use self-retracting brakes. There's all kinds of disc brakes available, and Joel did a great job of showing you where these websites are that you can look at this stuff. The MCP brakes we use on our go-karts that we race, and they're on a 450-pound go-kart that are running 100 miles an hour, and they can stop from here to that wall. It's really amazing how good those brakes are. So MCP makes really good brakes. I think that the drives that you use, you have to consider too. You can have a direct drive like a hub motor if it's allowed in your class, or you can have a chain drive and you can have a belt drive. I like the belt drive because it's really efficient and it doesn't have to be lubricated. The chain drives have to be lubricated to really perform very, very well. The array mount is a big thing. The array is very heavy for the most part, and the batteries are really heavy. So the mounts that you use for those things have to be able to take some abuse. They have to be able, if they weigh 200 pounds, if a battery weighs 200, battery insulation weighs 200 pounds, and you're going down the road and you hit a bump, you may impart into your chassis, say 3 Gs of acceleration. That 100-pound package is now going to weigh 300 pounds. So you have to remember that the little bolts that you use to mount that may need to be a lot bigger. And the brackets they go to may need to be a lot bigger because you have inertia. Whenever you hit something, you're going to have an impact imparted into the structure. So instrumentation controls, you can do all kinds of things. And now, we're using telemetry, and the other teams are using telemetry. It's a pretty involved thing for a first-year team, but you definitely have certain things that you're going to want to know. You're going to want to know the condition of your battery. You want to know the condition of your charging circuit, kind of your speed, several things. So you need to keep that in mind. Talk just a minute about composites, and I've got some samples of some composites I'll pass around. You basically got fiberglass, and there's 2 types of fiberglass. The strong one is the S-glass. And then you have Kevlar and you have carbon fiber. And that's the cloth. That's just like the cloth on this table. So it doesn't really have much strength unless you can hold it in its shape. And so you have to mix up a resin, which is also called the matrix, and you have to impart the matrix into the cloth. And then it's quite strong. I will tell you that when you get fiberglass and you put, mostly it's polyester resin, you put polyester resin on it, you can also use epoxy, and I prefer the epoxy. It's stronger and much easier to use. But when that gets hard, you're going to have a lot of little fibers on there, which when you don't have the hard resin on it, you can stroke them just like fur. They don't mean anything. But once they've got resin on them, they're going to get hard, and they'll be like a little needle, and you have to be very careful not to grab that with your hand or something, because it'll stick you in the hand. In fact, a lot of fiberglass parts, you don't want to rub your hand on them because you'll pick up those. You'll need to sand them a little bit just to take that condition away, to get those little needles that are sticking up. When you do layups, and most of them are done hand layups, where you put the cloth, you wet the cloth and put it down, and then take a paintbrush and dab on it to get all the bubbles and everything out. You'll have little fur pieces that stick up, and those you'll want to sand off after it gets hard. The epoxy resin is really good stuff. I buy my epoxy from West Company, which is a big supplier of that stuff, and it comes in a couple containers, and you've got the resin, and then you've got the hardener, and they've got a pump on it, and the pump is set up so that if you pump 3 of these and 3 of those, you have exactly the right measurement. The rest of the time, polyester resin normally comes with just a tube of a clear liquid. It's called methyl ketone peroxide, and that stuff you absolutely can't get in your eye. So you have to wear protective equipment when you're using that stuff all the time. But the fibers given off by the fiberglass, you want to wear the mask to prevent that from getting in your lungs. But I never can get the proportions exactly right, and it's dependent on the weight of the resin and the temperature of the day, et cetera, et cetera. So I really like the epoxies because they're just push the little pump, and as long as you match the pumps, you've got a perfect mixture. And the other good part is they don't smell. Polyester resin really smells horrible, and I don't like that. And it stinks up everything if you're in an enclosed area, and it really is bad. In fact, you don't want to be in an enclosed area. You want ventilation, and you particularly want to have ventilation when you're welding. I didn't mention that, but you got to have ventilation when you're welding, because welding always gives off fumes. But the The resin is just mix it and apply it, and you want as little as you can get as long as the part is soaked. You don't want a big, thick, shiny piece when you get finished. It should be a little bit of a matte discoloration to it, because you want to get some of the resin out. That's called resin drying and resin wet. Resin wet is not near as strong as resin drying. I think Joel covered some of the other stuff I was talking about, so we'll talk about fasteners. You know, fasteners, everyone thinks about nuts and bolts, and that's a fastener. But rivets, very much a fastener too. And the rivets that you need to use are aircraft rivets, not the kind you get at Home Depot. And the aircraft rivets you have to buy from a rivet supply company. They're not terribly expensive, but they are much superior to anything else you could use. Another type of fastener is adhesives. You want an adhesive that you can, and there's all kinds of adhesives, and you think of liquid metal or something like that, or JB Weld. JB Weld actually mixed up certain types of it, has 5,000 PSI of strength, which is a lot. That's a pretty high number. But you want an adhesive that's not brittle. So if you push on it, it won't crack and fracture all the way through. You want it to have a little bit of give to it. And the last fasteners are tapes and Velcro. Velcro is a great fastener for things you want to just stick on, like maybe a speaker or a light or something. It's a pretty good way to fasten things. The aerodynamics, you need to be thinking about aerodynamics all the time you're designing your car. You know, that's the flow of the fluids around the car, and air is a fluid. And the faster you go, the more it has an effect on your car. And we have very little power to overcome that, so you want it to go through the air as smooth as possible. And anything that sticks out into the air will have an effect. So you want to minimize all that. You want basically to kind of coax the air to come around. They want non-turbulent flow. Turbulent flow is if you have something that diverges from the flow of the air quickly, the air will lose contact with it and begin to swirl. You see this in a stream or a river when you see eddies around the bank of the river. You'll see these eddies flowing. That's a type of turbulent flow. So the other thing is talk to people about what you're doing. There are all kinds of resources out there. Other racers Joel mentioned the NHRA. You got a gentleman that was with NHRA. The SCCA, Sports Car Club of America. NHRA is National Hot Rod Association. You got IKF, International Kart Federation. Even NASCAR people. All these people love racing, and they'll help you any way you need. If you need something cut or bent or folded, or just some information or a source for something, you need to contact these people in the area that do that kind of stuff. You can go to one of their meetings and meet all kinds of guys who are colorful and really want to help you. The last thing I want to talk about is logistics. You need somebody on your team who kind of keeps track of everything. And normally that's the advisor, but a lot of what's going on just gets to be too much for the advisor. He's got quite a few other things to do. And, well, what is logistics? Well, what have you got? What have you got in your shop? What do you need in your shop? Where is it? Where is everything? Is it packed up? Or do you have something to pack it up into if you're going to go somewhere? All these things are logistics. So you need one or two people who keep track of the tools and the parts and the spares and where everything is. If you have a trailer, you're going to have some boxes that go in the trailer. They need to be marked. You need things to be accessible. If you need something, you're not going to have very much time to look for it. We're guilty of taking like a 20-foot trailer with nothing but boxes in it. We didn't mark any of them, so every time we needed something, we had to go through every single box to try and find it. So you don't want that. I can tell you that's not fun to do on the side of the highway. But get one or two people. Maybe they're not good fabricators, and maybe they're not good at some of the other things, but they can keep track of stuff. And that's your logistics guy. That's the guy that needs to be involved. And you probably need two, because if one of them drops out, you have kind of a backup. So I think in parting, I'd say learn the tools, learn how to use them safely. If you want to learn to weld, get a small welder and practice. If you want to gas weld, get a small gas welder and practice. It will take some practice, but everybody can do that. My experience has been girls are much better than boys at learning how to weld. So I think in closing, I'll say those are the things you need to concentrate on in your design. Make sure you put everything on paper. Any questions? Yes?
Where do you guys get that honeycomb fiberboard?
Oh, I'm glad you brought that up. I'm going to pass this around too. Here, you can pass that around. That's some of that honeycomb. And I've got some pieces that, if you'd like, you're welcome to samples. I've got a bunch of these cut up that, if you want one to take back, you can just come get one. This is one layer of 7-ounce mat. And it's amazing how strong it is. It's almost as strong as a piece of aluminum. And then here's a couple samples of the aluminum that you can play with. You can buy that material from Aircraft Spruce is a good source. And I believe we got ours. I forget where Shannon got it, but it's a floorboard of a 707. It came in a 4x8 sheet.
Can you tell me the specifics again?
It came as a 4x8 sheet, and it's used to make floorboard out of a 707 aircraft. And when you walk on the plane, that's what you want to know. He probably knows where to get all of that, more than mine. Joe, where do you get pre-made fiberglass or carbon fiber on honeycomb?
And let me also say, it's expensive.
Oh yeah.
And what you want to do is contact the company and see whether or not they're going to do a run of this material for somebody else. Now, Joey has some overrun. Ask them, can we buy that overrun? And it makes it far more reasonable. I'm sorry, there were some questions back there.
I think it's on the actual sheet that you print out. ACP office, they're in California. I don't know where in California, so I hope they're still there. And then dragon board. I'll tell you this: if you get a 4x8 sheet, half-inch single ply dragon board, it's $1,059, and that's before shipping. So if you do buy it, you want to buy more than one so that you can put that on shipping.
Yeah.
ACP in California, they will make it to your specification, and they kind of don't make it to the order, and it's about the same depending on what. So you really need to know what string you need, whether it needs to be 2-ply
Right.
or single ply. If you don't know, go with the 2-ply. It's pretty strong stuff. The honeycomb stuff's pretty strong. It's got better compression strength. If you get the foam core, which is cheaper, it doesn't have as good as compression strength. So if you're running like metal to it or bolting down to it, you want to cut metal spacers that go in there so that you don't compress that. Because we've had students that really cranked it down and just like squeezed it. We're like, oh. So you got to cut it out and replace it. But ACP and Dragon Blade are the two places to go get it. It should be on the source list of the work page. Or if you guys can email me, I don't know if my email's on that source page, but it's j@ringwellisd.com. I'll respond as soon as I can to any questions, parts, parts, or
Outstanding.
something that I've covered in the presentation.
Thank you, Mark. We appreciate it.
One last thing. When we started this whole thing about 8 years ago, we used to have classes for our students where we talked about all this stuff and taught them how to calculate bending moments and all this good stuff. And then COVID came and we couldn't do that. So we put together a handbook, what I call a handbook, kind of a design thing. And so I brought a copy of that for the teams. If you come over here and line up just the captains, one captain from each team, come over here, we'll get you a copy of that. And it has a lot of good information in it, and it'll help.
I appreciate
You're
what you've
welcome.
done on this.
Can I ask one last quick thing? You're Mark, right?
Yeah.
Okay. So in the past, we have used carbon fiber and the resin, and it'll set, but you have to put it under a vacuum. Let's say you can't, we didn't have access to a vacuum. You just let it set. How much strength do you lose? It's already super strong.
Not much. The purpose of the vacuum is to make it adhere the shape of the mold, to take the shape of the mold, and also to remove as much of the resin as possible. You put you're probably talking about pre-preg, you put that into the mold, and on top of that you put a device for absorbent. It's an absorbent sheet. It looks like cotton, and you put a sheet of that on, and then you put a piece on top of that called peel ply, and then, you put the peel ply on first, and then you put the cotton. I believe that's correct. And because the resin comes through the peel ply and into the resin absorbs it, and then you peel that off and throw it away. But the bag is just to push everything up in a mold. Is that correct, William? Yeah.
Because we had the materials
Yeah.
to make it cheaper, but the vacuum was always the issue we had.
No, you don't really need the vacuum if you have the right resin. You don't really need the temperature. But you'll still get the strength of the carbon. Okay. Is that right? Okay.
Okay, now's the time for the round of applause.
Thanks.